In this video tutorial, we are going to look into random forest model. So random forest is one of the most powerful ensemble learning techniques in machine learning. By the end of this video, you will understand how random forests work, their advantages over decision trees, and how to implement them in Python. So what is a random forest? Random forest is an assembly learning methods that build multiple decision trees and combines their predictions. It improves accuracy and reduces overfitting compared to a single decision tree. It uses a technique called bagging to train each tree on a different subset of the data. So bagging simply means bootstrap aggregating. The goal here is to create strong classifier by combining multiple weak decision trees. Okay, so how does the random forest work? So let's take a look at this figure. So we can show the process of random forest in 3 simple steps. So let's assume that we have got a training data set that consists of the target classes of the following lane cover classes. 0 is non-forest, 1 is forest area, maybe 2 is another lane cover class. And we have the predictor variables here, which are the lane sentinel bands. So we have a band 2, band 3, band 4 representing the green, red, and say near infrared. Right. So how does it work? So first step, we have the bootstrap sampling. So here, instead of using the whole training data set, so we are going to train the decision tree on a subset of the data. Okay, so the data is going to be sampled from here, and then it created different subsets of data. So some samples may appear multiple times, or others are left out. Okay, then after that, we come to the construction of the decision tree. So each tree is trained independently using its bootstrap sample. Okay, using each bootstrap sample. So at each split, the tree considers a subset of features in order to ensure diversity. Okay, so a subset of features by here I means it means the different bands that are considered in the classification for the case of lane cover classification. Right, then finally we have the aggregation of the prediction. Okay, so for the classification case as shown here, the final class is determined by majority voting across all trees. For the case of regression, the final prediction is the average of all trees. Right. So next, let's look at the random forest formula. So for the case of classification, as I said, the final prediction is the most frequent class. Okay, so this is determined by the majority vote. So it is very important to note that for the random forest, the key important parameter here to look out for is the number of trees that we consider, and also the number of the variables that are considered at each split. Right, for the regression, also it's important to note that here the final prediction is the average output of all trees. So that's the difference. Right, so let's just do a practical experiment here using the code below, as we have done in the previous videos. So we are going to build a random forest classifier in Python. Okay, so we are going to import the necessary library as we've done previously. Okay, and what we will do is we will generate a synthetic data set of forest and non-forest classification. So here we are going to consider 500 samples of the forest and non-forest, and then we are considering three features, which is the green, red, and near-infrared. And for this case, we are targeting only two classes, that is forest and non-forest. Okay, and if we okay, we are also going to split the training data set into training and test data set. Okay, so please take note here that X here is going to represent the predictors. So the predictors simply means the bands that we are going to use in our classification for the case of satellite imagery. So the green band, red, and near-infrared, and Y here is the target class. So these are the lane cover classes. So here we are simply splitting the data set. So this is what we are going to use as we work on a real-world data set. This is just a synthetic data set. So again, we are simply here splitting the data set into training and test data set. Okay, so the data set is going to have 70% for training, and then 30% for testing. As we usually, we are going to take this random state so that we can reproduce our code. So if you run this chunk of code, you are going to display the training data set. Okay, so this is the training data set. These are 500 points. So displayed in the with near-infrared and green bands. Right. Next, we will just generate this function, which is going to be used to plot the decision boundary in 2D space. Right. After that, we were going to train the model, and then here we are training the model with the different trees. Please take note. So for the first case, we are training the model with 100 trees, and I have only here put a maximum depth of 3 so that we can simplify the model. And we are also training another tree, another random forest with 500 trees and a maximum depth of 5. And then we run the model, and then we are going to visualize the decision boundaries. Okay, so these are the decision boundaries for the two cases of our random forest models. So the first model with 100 trees, and the second model with 500 trees. And note again, we have a difference in the maximum depth of the trees. So this is just for simple illustration. So we can see that this is the first decision boundary. We still have some cases of the forest area in the non-forest areas, and also the non-forest area in the forest class. And then this is the second case showing the 500 trees and maximum depth of 5. As you can see, the model tries a little bit harder now to try to distinguish between the forest and non-forest. Here we have this decision boundary taking care of these non-forest areas. Right, so this is all about the random forest. And just to conclude, I want to look at some of the advantages and the disadvantages of using random forest. So number one is you achieve higher accuracy. So some studies in remote sensing have shown that random forests achieve higher accuracy because it combines multiple weak models in order to reduce bias and variance. And it's a little bit resistant to overfitting because it is better than single decision trees because it tends to generalize well. Then it can also handle the missing values better than single decision trees. And more importantly, it also helps to identify the most important predictors, so we can analyze the feature importance. So we'll be looking at this when we run the random forest with a real-world data set. And the limitation here is that it is very computationally expensive. So that, for example, if we have more trees, that means we have to have more higher processing power, and maybe it takes a bit of time. But in summary, random forest is a powerful ensemble method that improves accuracy for classification and regression purposes. Again, it reduces overfitting. It's good at handling missing values and provide feature importance. So in the upcoming video tutorials, we'll be looking at these methods in detail. Okay, so thank you very much for watching. See you in the next one.